Shall we? Ethan,
What?
shall we start?
Oh, sure.
All right, let's do it. So it says in here, a small balloon is released at a point of 150 feet from the observer. So let's claim this is the observer, the person, and it's 150 feet from where that person is, and the balloon exists right about there. Who is in the ground level? If the balloon rises straight up at the rate of 8 feet per second, since this is the rate, we could claim that this is your dy dt, which is equals to 8 feet per second. How fast is the distance from the observer to the balloon when it's increasing? When the balloon is increasing 50 feet high. So they're asking us how fast is the distance. The distance in this case will be your dz dt. It's missing when we're looking for it, provided that the height is equals to, or in this case, your y value is equals to 50 feet high. So we have our setup. Since this deals with the triangle, we're going to be using the x squared plus the y squared is equals to z squared. We have a z value, we have a y value, which we're going to plug in a little bit. And right now we're still missing a z value. Though we're looking for a dz dt, and we do have a value for the dy dt, we need to find the z value. And we can use that in terms of the Pythagorean theorem. So it will be z squared is equals to x squared plus the y squared. Z squared is equals to 150 plus the y, which is going to be 50 squared. Okay, squared. So z is equals to radical 150 plus squared plus 50 squared. Z is equals to radical of, what is that one? When you actually add that up. 150 squared plus 50 squared. 25000, and that could be simplified as just 50 radical 10. So that's your z value. So now let's find the derivative of this given formula that we have. It will be 2x dx dt plus 2y dy dt is equals to 2z dz dt. You could plug in 2 times the value of x, which is 150. But remember, dx dt is equals to what? If you have x is equals to 150, what will be its derivative?
0.
It goes to 0. So that whole thing's to 0. And then we're left with 2 times the y. dy dt is equals to 2z dz dt. Now, I wanted my dz/dt to be on its own because that's what we're solving for. So now we have 2y, 2z dy/dt is equals to 2z dt. The 2's cancel out. We're left with y over z dy/dt is equals to dz dt. Now we could just plug in the following that we already have. Your y value that was given was 50 over the z, which is 50 radical 10. dy dt happens to be 8 feet per second. That gives us a dz dt value, which is the 50 cancels out. We're left with 8 radical 10 feet per second, but we could simplify that by multiplying top and bottom by radical 10. That gives us 8 radical 10 over 10. And that could be simplified to just 4 radical 10 over 5. And that will be feet per second. That will be your dz dt, the rate of which, how fast the observer from the the observer to the balloon when it's 50 feet high. Zoom out too much in it. Any questions about this? No question? Does anybody want me to zoom out first so that you can do a screenshot or something? Can we proceed to the next problem?
Yeah.
Yes, no? Okay, thank you. All right, next problem, number 11. It says the sand is falling into a conical pile at a rate of 12 cubic feet per second. Conical pile, yes. The sand is falling off, and the rate that will be your dV dt is equals to 12 cubic feet per second. Per second. And it says that the diameter of the pile is 4 times its height. So if the diameter from here to here is 4 times, that's your d, is 4 times its height, so you could say d is equals to 4h. Or else did they ask us, at what rate is the height of the gone? Back again. So we have a conical shape. Sand is falling off. We have the diameter that is, that's your d value, and the height is 4 times. The diameter is 4 times its height, so we could say d is equals to 4h, and they've given that the dv dt is equals to 12 cubic feet per second. They're asking us what is the rate of the height, so that means we're going to have dh dt missing, provided that the height is 8 feet tall. Okay? So the formula we're going to be using, I think on the exam the formula is provided for us, but the formula we're going to be using for the volume of a conic shape will be 1/3 pi r squared times the height. Okay? So we have the dV/dt and we're looking for dH/dt. They didn't mention anything about the dR/dt because we have the B, we have the R, we have the H, but dR/dt is not provided. So what we're going to do, we're going to use the knowledge that we know that the diameter is equals to 4h and replace or substitute the R value in terms of the H's. Okay. So we know that if the diameter is 4 times the height, that means the radius is equals to 2 times its height. So now let's just substitute. It will be V is equals to 1/3 pi times the R value, which is 2h raised to the power of 2 times the height. Now let's simplify this. That gives us V is equals to 1/3 pi times the 4h cubed. Because we have the 2 to the power 2 times the h to the power 2 times the h, that gives us 4h cubed. So now let's find its derivative. This gives us v dv dt is equals to 1/3 pi, 4 times 3, that gives us the 12, h to the power 2. We could simplify the h dt. We could simplify this as dv dt is equals to 12 times 12 divided by 3, which is 4 pi h squared dh dt. And let's plug in the one that was given to us, which is the dv dt. That will be your, let me just put it on the other side, your 12 cubic feet per second is equals to 4 pi times the h. Your h in here that was given was 8 to the power of 2 dHdt. I just plug in the ones that was provided for us. Your dVdt, dVdt is given, and then your height is given. So now let's solve it. Let's get your dHdt by itself. So this gives us 12 cubic feet per second is equals to 4 pi times 8 times 8, which is 64 square feet, dHdt. Now let's move everything on the other side. That gives us 12 cubic feet per second divided by 4 pi times the 64 square feet is equals to dHdt. Now all we need to do is to simplify. 12 divided by 4, that gives us a 3 on the numerator. So that gives us a 3 over 64 pi. And then we have the cubic feet and cubic squared. Not cubic squared, square foot. That gives us just feet per second, which is your dHdt. You can plug it in as a decimal if you want, depending on the multiple choice that was given to us. So that is the rate of the height as the pile changing with the height. That is 8 feet. Any questions on that one?
Did you say that the formulas are going to be on the test?
I'm sorry?
Did you say that the formulas are going to be on the test, or do we have to memorize all of them? Like these kinds of shape formula thingies.
Let me double check. I'm pretty sure, I mean, I printed it out today. I saw that it's there. Let me just see. This is not the same as the one last year, the test that I've given from last year. Grab this. Formula is given for one of that. Kept the formula twice now. Yep, for the conic shape, the formula is given. There's 2 of them that does with a not conic shape. Related rates. 2 of them, 2 of the problem out of 16 questionnaires have related rates to problem 1 and 2, and the formula is provided.
Okay, cool. Thank you.
All right, number 12, I'm going to skip. We already had a problem like this on the notes that just deals with the isosceles triangle. We have the length, the width, and the height. So that was already, I want you guys to go over quite something like this, but it should be fairly easy. Okay, number 12. So I'm going to skip that. Let's go on number 13. That does with finding linearization of a given function. It says that here the function is twice differentiable. That word twice differentiable is not necessary because for the linearization, it will just be a formula of f of x, approximately L of x, to be equals to f of a plus f prime of a times the x minus a, where the a value in here is equals to 3. I'm sorry, that's your a value. And your 2 will be your f of a, and your f prime of a is equals to 4. And it's asking what is the value of an approximate point, which is 2.9. So we have to use the linearization to actually figure out the value of 2.9, the value of x, using that linearization. So let's do that. F of 2.9 to be approximate L of 2.9 to be f of a, which is the 4, plus the f prime, which is 4 times the 2.9 minus the 3. Oh, that should have been a 2. I'm sorry. I made a mistake right here. F of a should have been a 2. Because this is your f of a, which is 2. And your x is equals, or your a is equals to 3, your x is 2.9. Okay? So now this gives us an approximate of 2 plus 4 times, was it 0.9, 0.01, or is it 0.1? 0.1? All right. Negative. And that gives us an approximate of 1.6. And that is it. Okay. The only thing that you really need to know about this problem is the formula itself. And that's it. If you got the formula done, everything is good to go. Okay. Now, number 14, it's quite the same thing. The only difference is that instead of you giving a point, what you have is an actual equation. So number 14, we have the value of x is equals to negative 4. To figure out your y value, you plug it in. 3 times negative 4 minus the 7. That gives you a value of y, whatever that is. Now, to find your derivative, your f prime of a, all you need to do is to find its derivative, which is just 3. So you have the following values: your x, which is negative 4, your y value in this case is, y is 3 times negative 4 minus 7 is that, what is it? Anybody? Nobody cares. Are you guys still there? Negative 12 minus 7, what is it? Negative 19, thank you. And that's it. I mean, you have to set it up and then plug it in this given equation that we had. Find the value of this one. It is not as bad. Any question on this? I'm not going to finish it because the answer is going to be negative 16. But let's move on. 15. Number 15 is the same thing as number 14. A function or an equation is given to us, but we are given the value of a, which is the 2, your f of a, which is the 5, and your f prime of a is an actual function. So let's figure out f prime of 2, which is 4 times 2 to the power of 3 all over 2 to the power of 2 minus 2. F prime of 2 is equals to 16. So now it says use the linearization to estimate. So it'll be f of 2.03. Give me an approximate L of 2.03. The approximate f of a in this case is the 5 plus f prime, which is the 16 times the 2.03 minus the value of a, which is the 2. And that should give us the value of 5.48. And that is it. I think the linearization problem is the easiest of all that we've had so far. Any questions? No? Maybe. Can I move on to L'Hopital's rule?
Yeah.
Okay, thank you. Let's do some. So for the L'Hopital's rule, you can't just say, hey, I have to use L'Hopital's rule because it's the easiest one. We have to prove it step by step. So step number 1, we have to show that once you apply the limit, the numerator and denominator, it's either going to be 0 over 0, it could be infinity over infinity, negative infinity over infinity, and all that stuff. So let's do this. So if I have step 1, limit as x approaches 0 of sine of x, that gives us sine of 0, which is just 0. Now let's prove that the limit as x approaches 0, the denominator 7x plus 2 times the sine of x. That gives us 7 times the 0 plus 2 times the sine of 0. That gives us a value of still 0. We could say that it is indeterminate. Therefore, use L'Hopital's rule.
L'Hopital's rule.
So let's apply it. Number 4, let's use L'Hopital's rule. So let's find a derivative. The limit as x approaches 0. A derivative of sine of x happens to just be a cosine of x all over the derivative of the denominator, which is just 7 plus 2 times the derivative of sine, which is cosine of x. Now let's plug in the value of x, so cosine of 0 all over 7 plus 2 times the cosine of 0. Cosine of 0 happens to just be 1 all over 7 plus the 2 times the 1, which is just 1 over 9. Here. Was it too fast? Are we okay?
We're good.
Yeah, we're good. Thank you. Number 17. We have e to the x minus cosine of x all over 5 sine of x. So now, again, let's prove it again. I know it seems redundant, but it's worth doing it, especially when you're doing your AP testing itself. Before you could say, I could use L'Hopital's rule, you have to prove that you're allowed to use L'Hopital's rule. So let's do step 1. The limit as x approaches, approaches 0 for e to the x minus the cosine of x. That becomes e to the power of 0 minus the cosine of 0. That happens to be just 1 minus 1, which is just 0. Number 2, the limit as, or step 2, x approaches a 0 of 5 times the sine of x. That would be 5 times the sine of 0, which is just equals to 0. Since we could say it's indeterminate, therefore use L'Hopital's rule. Now let's find its derivative. So step 4, the limit as x approaches 0, derivative e to the x, still e to the x. The derivative of cosine will be negative sign, but we have a negative, so that becomes a positive sign. All over the derivative of 5 times the derivative of sine of x gives us just cosine of x. Okay. Now let's plug in the value of the x. We're going to apply its limit. So e to the power of 0 plus the sine of 0 all over 5 times the cosine of 0. E to the power of 0 is just 1 plus the sine of 0. That happens to be 0 all over 5 times the cosine of 0, which is 1. That would be just 1 over 5. Any questions? Any questions at all?
No.
Yeah. I'm just trying to double check something here. Minus 3x squared. Yeah. All right. Now in here, if I apply the limit rules for this one, I said the limit as number 1. as x approaches infinity of 5x squared minus the 7x. And we apply as x approaches infinity. If you actually try to graph it, since x squared has a faster rate than the linear negative 7x, so we could say that that goes to infinity. I mean, it's a problem. So as x approaches infinity, what happens to your value of y? It goes to infinity. Number 2. The limit as x approaches infinity of 1 minus 3x squared. Since that's a negative for the parabola, it goes downward. So as x approaches negative infinity, the value of y actually goes to negative infinity. So it's going to be infinity over infinity, so that will be an indeterminate. 3. Indeterminate. Therefore, use L'Hopital's rule. So now let's find its derivative. So the limit, this is number 4, as x approaches infinity of 5x squared, that gives us 10x minus the 7 all over 1 minus 6x. Since we have a linear over a linear, it's still going to be infinity over negative infinity. We have to do L'Hopital's rule all over again. The limit as x approaches infinity, that gives us 10 over negative 6. Since there's no more value of x's, it's just a constant, we could actually reduce that to 5 over 3 negative. And that is the limit as x approaches infinity of that given function of 5x squared minus 7x all over 1 minus 3x squared. Any questions on that one?
Couldn't we just use the exponent rule?
You could use the exponent rule. Absolutely. There's multiple ways of doing it. I don't want to do it the way they're doing it, but it can still be done that way. Like if you divide top and bottom by the highest exponent on the denominator, you could do that. Absolutely. I don't want to, but it's the same thing. I just want to be consistent. Okay. I'm going to skip number 19. It's quite the same thing. You're just plugging in an actual value for your x's, which is 2. And then you keep doing the derivative until it actually gives you a value. Okay. Let's go to number 20, the last part. So number 20, I have to find the limit as x approaches negative infinity of x squared all over 1 minus, or e to the power of 1 minus x. So in here, step number 1, the limit as x approaches to negative infinity of x squared. If I try to graph x squared, still a parabola. As x approaches to negative infinity, it goes to positive infinity. Now, the limit as x approaches negative infinity, the denominator, which is e to the power of 1 minus x. We know the graph for e to the x. Do you know the graph for e to, I mean, I'm pretty sure you guys, most of you guys actually know the graph for e to the x. The e to the x, this is e to the x graph. But now this is e to the power of 1 minus x, so it's actually a negative. You could say e to the negative x, that would give us, just put it on, just to confirm. Just want to make sure I'm getting that right, because it would reflect to the other side. And having 1 minus, or e to the power of 1 minus x, it's just going to be shifted a little bit to the left side or right side. I think it's going to be to the 1 minus x, so x is equal to 1, and be shifted up to the right. So it will behave the same way. So x approaches negative infinity, goes this way, your value of y goes to positive infinity. So that's still infinity over infinity, so therefore we could use L'Hopital's rule. Use L'Hopital's rule. Uh, So now number 4, we could find the derivative, the limit as x approaches negative infinity of x squared, which is just 2x over, so you copy the e, and then you find the derivative of the exponent, which is just negative 1. Oops, it's glitching. There we go. So we have this. So now we have a linear function e to the power of x, a linear graph, or not e to the power of 2x. That will be a linear graph. So as x approaches negative infinity, your value of y goes to negative infinity. Now, negative e to the negative x, that just still goes to negative infinity. It will flip. This one, e to the power of negative x, since it's negative, it would flip in terms of the x-axis. So this will be, look like this. This is your negative e to the negative x graph. So as x approaches negative infinity, your value of y goes to negative infinity. So that would be just infinity over infinity. So now we got to find its derivative again. So the limit as x approaches negative infinity, the derivative of 2x would just be a 2. The derivative of e to the power of 1 minus x with the negative on the outside, let me just write it down. Negative 1 times another negative 1 again, because the derivative of 1 minus x will be a negative, so that becomes a positive 1. Okay? So now this becomes, when x is equals to negative infinity, approaches negative infinity for 2, it still remains as a 2. But now the denominator, as e to the power of 1 minus x, as x approaches negative infinity, going back to the graph that we have right over here, as x approaches to negative infinity, that becomes a bigger value. It's a large number. So if it's a fraction, 2 over some big number, it approaches to 0. And that is it. That's all we have for today. All I'm going to add to this is that, remember in the notes that I was doing with you guys, and I would say, there a portion in there, and I would say, hey, this section will be on the test, or it will be quite similar to the test. Mark it up. That's the one I want you guys to go over on your own tonight before the test tomorrow. Okay? You guys are on your own. Good luck. I'm pretty sure you guys are going to do well. There's 7 questions that deals with no calculator, which is tomorrow. And then the following day, you guys will have a portion that will be with calculator. Overall, there's only 16 questions. I took off the free response. Okay? Make clear?
Are we able to use like a dumb calculator, or no?
For the sake of our class, you're allowed to use the dumb calculator for first part. Well, I don't think you needed it, to be honest with you. But yeah,
Okay.
you can.
Cool.
Okay? And that's all I have for today. We finished it.
Thank you.
Just don't forget, go over the notes that I asked you guys to do. Okay? You're welcome. All right, I gotta go make dinner or do my homework. See ya.